Okay, perfect. Good morning to everyone. I'm very happy to see you here another day with this adventure about knowledge of programming computers with logic. Um, I just finished my Spanish lesson and I realized um, it's hard for my Spanish student too. So don't worry if you are any question or you think that will be hard, because that is not hard only for you. For people who already program computers many years ago, it's not an easy task. So don't worry, we're going to do very slowly, step by step. And if you have any question, please don't worry to ask me at any moment. Okay. Okay, nice. I started to translate new version because there are a previous translated version of the document, a book we wrote it some years ago. But this translation was an automatic translation that was not very, there are some things that are not translated, like the name of variables or other things. So I am trying to create this new book. I'm probably in the future leave this book, I don't know, for free or you have this book. I leave this book for you here in this Moodle. Everyone, sorry, I'm going to share my screen. Everyone have access to Moodle or not? There's someone who has some problem to access to Moodle platform and to access this subject of knowledge representation. Not everyone. Okay, it's very important to have access there, because for any notification I have to send to you, I will use this forum here, and I write here a new subject, and you will receive an email. If you are not here, probably you will not receive the notification for any change of date of classroom or whatever information I will send you here across this platform. Okay, nice. Here you have two declarative programming files. The first one is the version 1, is the version I told you is an automatic translation. Sometimes there are some things that are not good because it's one automatic translation. I want to show you. I think it's this one. Yeah, this book. So here is like you have everything more or less translate, but sometimes some variables are not. For example, here it's not aristas, it's in Spanish. Some parts of this book is in Spanish. So now I am changing everything. Probably you can use both. This version probably will help you, or other version is this one, where I am trying to translate everything and with examples also in English. But it's well, it's a hard job, try to translate everything. So I am doing step by step. I hope at the end of the semester, everything here will be translated more or less. And at the beginning, if you take this, you can find this file here is the creative programming version 2. I added the information of partially translate because there are some parts that are not translated at this moment. For example, if you take a look, we are here in page 53, but if you go to the beginning, you will see some parts that are in Spanish because this book have covered two different programming languages, declarative, like functional programming, and declarative programming. So, sorry, functional and logic programming. We're going to use logic programming with Prolog. So, if you download this file, you can go to page 57, and we can take a look to the information there. This book can help us, will be like a guide or map to the to see the content we're going to follow in this semester. So first part of introduction is at the beginning, here, page here, 51, page 51 is the first part of the document. We have the introduction. Many things here in this introduction we already see, but we're going to follow that in order to don't leave any important concept without see. So, as you know, this subject is using logic, mathematic logic to create programs. And there are two parts or two different parts of logic are propositional logic that are like very simple statement or propositions. In this type of logic, you are not able to use variables. So it's more complicated to describe things using propositional logic. Now, here you have some examples. Here, for example, say logic program is a knowledge base as queries or questions. We'll make questions to Prolog and wait for answers. In this case, in the first example, we don't have variables, only simple statements without variables. This example it's very simple. It is rain. Plants are watered. That means it's raining, plants will receive water. And the second part of the program is the fact that says, okay, now it's raining. So I can ask, if I take that in a program, we can do some questions. I'm going to show you a different way to test your program, because there are someone who have some difficulties to install Prolog, no? Who told me last day who have some difficulties to install?
I was it, but I think now everything should work.
Okay, you have another option, is use this web page. I'm going to share you in the chat if you want to take a look. Here is this link. In this link, you will access to this online version of the compiler or Prolog interpreter. If you access here, you can create, for example, a new program, and you can paste here the code. Sorry, it's not this one, it's this one. You can paste this code here and check if this program works or not. Here, papa. Remember, these symbols means this is a comment, and the interpreter ignore this line. So this line is not part of the program. It's always an explanation to understand what is happening here. Here, I think there's an error. Let's go to see, because this is very extremely simple program, and I don't know if that will work. For example, we can ask if it rains, and Prolog say it's true. Why Prolog say that is true? Because there a fact is this fact that make this phrase true. And when after include this information here, Prolog say, okay, that is true. I'm going to show you other thing is that I created I am uploading the code to this place where you can check at any time if you need some program. Where you see in the classroom, we can access here to this address. I'm going to share this address in chat, where you can access and see the code, any program we create in our lessons. Here, for example, natural number. You have here, this is the code. Okay, let's go to copy this code and paste here to check if that works. Okay, this line from 1 to 5 are some explanation. This is code, line 6, part of the program. This is also explanation and the second part of the code. And now we can ask, for example, if natural 4 is true. We'll ask several. Okay, Prolog, that is true. Natural number 4 is true. And Prolog say, it's true. a natural the 3.5 is true. And Pro say, no, that's false. Or natural the 0 is true. Pro say, no, it's false. Okay, you have also this option to run the code using this web page. If you have any problem or you are in a computer where you don't have installed the Prolog, you can use this version. Okay, let's go to continuing. So we have two different type of logic. Is predicate first order logic, and then we have this predicate logic, where now here the concept include the option to include some variables, and now this is more powerful for us. We can express more things in a more simple way. So this is the way we're going to do with this. It's like our water, parentheses, and what. And here in this variable, we can change and put inside many things. For example, here are tomatoes, or lettuce, or strawberries, or whatever. So that help us to create more concise and more expressive programs with these variables. So we're going to use this logic of predicates. And now the next part of this lesson talk to us with this subset of logic, that is the programs we can write with horn clauses. Let's go to see what that means, what this horn clauses means. Okay, you have to know that they are a program that take our rules, our clauses, for example, you know what a clause, what that means? This word, what to say to you? You know what that means or not? We call a, yes, you know that? Good.
It's like a condition or something like that, no?
That is a rule or a fact. One of the things is something like I write in only one line in Prolog. Start with the beginning of the line and ends at the dot. This is when I talk about clause, that would be a rule or a simple fact. One of these things. So this is like the things we write every single line in our program from the beginning of the line until the dot. This is a clause. They are a theory related to this to the algorithm that take all these clauses, these rules and facts, and resolve and tell us if something is true or false. There a program, we call this algorithm of resolution, or resolution algorithm, that what this algorithm do is take all the rules and facts that is called a knowledge base and try to tell us if whatever question is true or false. So this resolution algorithm take all the information we give this knowledge base and try to resolve if something is true or false. It's something that happens automatically. The programmer don't need to pay attention about that. It's something that is totally transparent for the programmer, but you have to know that that is something behind that do this job for us. It's not only the program, our program that resolve a question, is this algorithm that take any part of our program trying to resolve if that question is true or false. And this algorithm, there a theory of computability. It's not, you only have to know, it's not important to remember that, but you have to know that there a theory of computability, that this area of knowledge work about what programs can be, or what problems can be resolved or not with a computer. This part of knowledge try to tell when a problem can be resolved with a computer. Sometimes some problems can be resolved with a computer, but there are another problems that is not possible to resolve with a computer. So this theory help us to know if something will work or not with a computer. And for us, the important part for us is that there are results of this theory of computability related to logic programming that say, okay, if you write a program only with horn clauses, we can assure that this program that resolution algorithm always with an answer. So the important thing about this theory of computability and resolution algorithm is if we only write horn clauses, this type of clauses, we can affirm or say or that this algorithm that help us to obtain the solution for our question always finish giving us an answer. If I use other things different of horn clauses, I can't affirm that. sometimes will work or sometimes not. So our programs always, we are only right on clauses and our programs. So we are going to use this subset of logic that is called the subset of rules that we can write with this type of clauses. Okay, it's very easy. Now we are going to see what is the different or what type of are the characteristic of these horn clauses. We're going to see, and you have to know that all elements we write in our programs are clauses of this type. Okay, what is the aspect of these horn clauses? Clauses is one horn clause is something of this type, is one or more elements in antecedent separate by and. I'm going to write it this way. Term 1 and term 2 and term 3, and only one term inconsequent. Term, let's go term 4, whatever. Okay, so we will have one horn clause will be something like that. It's like terms in the antecedent, term in antecedent. This is the antecedent of the rule. This is the antecedent of the rule. And only one term here in a consequent. Only one term in consequent and one or more terms, zero or more, because the fact will be when we have zero terms here, something like only term and dot, that will be also a clause horn. So here, 0 or more terms separate with and connector, and that means that is true and that is true and that is true. If all that is true, then I can say this term will be true. And only one here, only one inconsequent term here in a consequent. Okay, this is the aspect of these horn clauses. 0 or more terms here, separate by and. I'm going to write it in capital letter, a little more clear. And only one term inconsequent. Okay, if we write only this type of rules, of clauses, we can affirm, we can say that the resolution algorithm always finish. That is very important for this automatic process. If not, this cannot be done in automatic way. It's very important for us because we are going to give this knowledge base to the computer, and computer will give answer to us. Okay, any question? This is a little theory part. It's very, very small theory part, but it's important to know what are we doing. And it's only probably the only theory part of this semester. This only information about horn clauses. Okay, any question? Probably for many of you, this is the first time we listen about this computability theory, but it's only an idea to have this concept that will be interesting. If something talk to you about theory of computability, you have to know that they are a part of knowledge that try to resolve which problem can be resolved with a computer and which problem cannot be resolved with a computer. Only that. Okay. Nice. Any question? No. Yes. Any question? No? Are you happy? Are you happy? Yes. Lucas
I have
says
a question.
Laura, tell me.
Could you scroll down a little bit, please?
Sorry?
Could you scroll down a little bit?
Yeah.
So in the horn clause where you have term 1 and term 2 and term 3, do you need to put a point after that, or don't you need that?
Yeah, I write that is in logic form, more or less, but in Prolog.
Okay, so in Prolog you will
Prolog,
need that, but
yeah, in Prolog we changed that. In Prolog will be something like that. Term 4, 2 point. It's like we change the order.
Okay, yes, I see it.
Term 1. A very good question, because sometimes we'll be confused, because sometimes I use a logic representation, classic logic, but in Prolog we write in this way. Term 2, term 3, and dot.
Okay.
And
thank you so much.
You're welcome. Here, the comma means and. I am telling to Prolog, okay, term 1 have to be true, and we will read the comma, as and in Prolog. Okay, so every time we will see a comma, that means for us and. That is true, term 1 is true, and term 2 is true, and term 3 is true. And if everything here is true, I can say, okay, if everything here is true, term 4 will be true. Okay, this is a way to represent this logic statement in Prolog. With this changing the order, we write the antecedent in the right side of the rule and the consequent in the left side of the rule. And this is the antecedent. Sorry. This is the consequent of the rule in Prolog at the beginning. And this is the antecedent. Just in the reverse way, like logic represent usually. It's just in the different way. There are a reason why to do that is something related to resolution algorithm. It's more easy because they have to check here. It's more easy for the algorithm to have this representation. Don't worry about that. You only have to know this is change the order, and that's all. Okay, perfect. Let's go to see some things about Klaus horns, and it's only 4 examples, and we can continue with more exercises. So you can also, this symbol, this symbol is like this. That means and in logic too. So you can find in logic this symbol is equivalent to and. So in this case, this is a horn clause, is something like A and B, then C. This is a classic a clause horn with two terms at the beginning in the antecedent. And for example, what happens if I want to represent that? Something like A, if A is true, then B and C. This is a horn clause or not? This part, I want to write here. It's like A and B, and then if that is true, then C. Sorry. A, then C, and B. B and C. Okay. This example is a horn clause. This example, yes or not? What do you think? Is a horn clause or not? According to the definition I just give you, is this a horn clause or not?
Well, it was written, but it is not.
So
You
it is
understand,
not.
right?
Okay, yeah. So I just say no, it's not. Why not? What is the rule this example break? Why this is not a horn clause?
We can only have one term in the consequence, right?
Perfect. And here we have two terms. This is antecedent, and here we have two terms in consequence. So this is not a horn clause, but we can find a translation. Translation of this is something that you can express in logic. It's perfectly you can express that. If something happened, for example, is if I going late to work, for example, if I'm going late to work, I can say, okay, if this happened, I can take the bus or take my car, and what more? Take my car and for example, don't drink. I don't know. Whatever. I'm late. I have to go fast. I have to take my car. I cannot go working, and I don't drink my tea because I have no time. So this is not a horn clause, but I can translate that in two sentences or two rules in this way. If I am going late to work, I can take my car. And this is one rule. And the second rule, let's say, so what we're going to do in this case, if I want to express that, what I'm going to do is to separate this rule into new rules. Okay. We separate this rule that is not a horn clause in two separate rules. Okay, this is the first translation for our example of something that is possible to express in logic, but not in our programs. Second example is this one. I say, okay, if I want to say if A or B, then C, something like A or B, then C. For example, if, for example, if it rains or it rains or it snows, then use my coat. For example, okay, if rain or snow, in any case, I will use my umbrella. Is this rule of in the form of horn clause or not? And that's in capital letter. Is this a horn clause or not?
No, it's not, because we can translate it in two rules also. Like the rules,
Yeah.
if it rains, use umbrella, and the rule it's
Yeah.
snows,
It's,
umbrella.
but it's not, because there are two terms here in the antecedent, but are separate for one or. If that is true, or wherever, it's not the two at the same time, it's one or other. It's not a horn clause, and we can translate that in two different rules, as we can see here. Is A, then C. We can say if it rains, then use an umbrella, and if it snows, use an umbrella. In two separate rules. In this way, okay? So if I want to express something like that, if that happens, or other thing happens, then wherever, I can translate that into these two simple rules. Okay, more things. I think it's the last one. A, then B, or C. What that means. For example, if sun is shining, then go to the beach or go to the mountain. For example, something like that. If something happened, in this case, for example, it's sun shining, you can go to the beach or go to the mountain. So is this a horn clause or not? Yes or not, and why? Why is not a horn clause? Why not? According to the definition I just give you, why not? It's not a horn clause. Hello. I want to start to ask. Very easy, no? It's not because there are two elements in consequent. So it's not that broken the rule. There are two elements here in consequent. So it's not. But here happens something different because if you think about this rule, that it's possible to express in logic, but what do you think if that happens and I want to express that in one computer? Think about that. If shiny, I will go to the beach or I will go to the mountain. Do you think it's possible to know with this information that sun is shining where I will be or not? Or here we have something that...
Well, you don't know. The only thing is kind of that you know you go outside, but else you don't know beach or mountain. Nobody knows.
Exactly. And computers don't know how to deal with this type of information. Computers only know to path something that always happen in the same way. It's not possible to say something that is try to express something like that. It's an indetermination. It's like this is an indetermination. It's not possible to say what will happen. It's something like you ask to the computer one day, one moment can give you one answer, and another moment can give you an answer. That is not what happened with computers. Computers always, more or less, we can simulate this type of information or knowledge, but they are random information too. We can ask things, and sometimes we give one answer and other moment can give a different answer, but we need determination. And this is not possible to express with our logic programs, okay? So if something like this appear, I cannot express inside my code, okay? So like that. Okay, nice, perfect. That is a little part of theory. I think it's interesting because in this way you can understand more or less that there are these resolution algorithm that is very important to know, to understand that there's something behind this code that will resolve for us and give solutions to us. It's not only like in imperative program, that in imperative programming you give everything to the computer, but now we have some extra help. It's something similar to the example of surfing will be something similar to if you try to drive a car, you need an engine that gives you the energy to move. But when you are surfing, you have an extra help. Is the wave. The wave are pushing you. So you have an extra help, an extra engine, something like that. Okay, here we have an extra help that is called resolution algorithm to resolve things. Okay, so we have not to pay attention about everything. We'll try to express one concept using logic and induction principle, mathematic induction, and after that, this system or algorithm or resolution can give us the solution. So for people who programmed before in other programming languages, you have to know that we have an extra help. Okay. Another idea before continuing with another exercise is we have to know that we had this closed word hypothesis. That means everything that is not defined for Prolog will say to us that is false. If I want to ask for something that is not I not write in my program, Prolog will tell us that it's false. Sometimes if I write to ask for something that is not right, Prolog can give us an error, like say, okay, I have no definition for that, but we will see other examples where if I don't write some element or a solution for one type of list, for example, or Prolog will give to us the answer that is false. That is very important. We will see many examples about that. Okay, perfect. That is the first part of an introduction. Here we talk about variables. We also talk about variables. That is only to remember what we saw before. How we write variables in Prolog? Who can tell me? Here are two concepts we see last lessons. One is how we difference in Prolog a variable from a constant, for example. Who can tell me? How we write variables in
You
Prolog?
need a capital letter.
Perfect. Variables starts with capital letters. There are some examples. Person, list, x, tree, whatever. Perfect. There are some programming languages that when you define a variable of one type, for example, in some programming languages, I can do something like that. I can say, for example, int c. That means c, variable c, is an integer. C is an integer. And when I define that variable, that will be, for example, the programming language C or C++, or whatever. When we define a variable in this type, after that, it's not possible to do something like that. C is equal to list 1, 2, 3. Because define a variable type, that is a way to reserve or make a reservation of memory resources in computer. So that means, okay, this is a very small piece of memory. You only need a small piece of memory to save an integer, but we need more resources to save a list. So it doesn't work. It doesn't work in C. Programming language. Okay, it doesn't work because when we define or a variable, we are reserving some memory and resources for store those information. But in Prolog, we don't do that. We don't need to say, okay, this is an integer or this is a list. We only say, okay, this is a variable, this is a x, and I can do something like that. X is a number, we'll unify with a number, And at the same time, what do you think about that? X unified with a list. What do you think about that? Do you think that is possible in the same line or not in Prolog? But if I ask here to Prolog, okay, Prolog, X unify 1, X unify with a list 1, 2, 3. What Prolog say? Prolog say, can someone tell me what Prolog will say to this question? We saw that in the previous lesson. We was talking about that, what is the scope of variables. What do you think about that? That is possible? This is the concept of mathematical variable and variable in computer science. What do you think? What Prolog will say to this? To this question? We need a break. I think we need a break, a small break. I am telling to you many things, many ideas today. Okay, let's go to do a break, a little break. Okay, let's go to stop 5 minutes and back again, because I want to remember, we were talking about that, but I want to remember about this idea of mathematic concept of variable and classic computer science concept of variable. Okay, so let's go make a stop around 5 minutes, and we'll back in after this time. Okay, see you in 5 minutes. ¿Qué tal? How are you? Sorry. Let's go to continue. I'm gonna share my screen. Okay. Are you okay? Are you alive?
Yes.
Yes. Okay, nice. Probably that is this is the harder probably, but for me is I don't like to spend many time with the theory. So that is all that concepts we also see in the previous video or lessons. Who can tell me about the difference about variable in mathematics, or sorry, in computer science, classic computer science, and the variable in mathematics? What is the difference? Who can tell me?
In mathematics is something that can change, and in computer science is something that stores information.
In computer science, you can change, yes, because, but why? You can change because the concept is more similar to a box, no?
A box, a container, yes.
Yeah, so it's related in computers, in classic computer science, a variable is something like it's like a memory address where you can store things there. And what is the concept of in mathematics? What is the difference? When we use, what is the way to use variables in mathematics?
It's something that can be substituted for.
Substitute?
Something you have to fill with something.
Not exactly, no. It's not something that it's something that help you to describe a concept. So we're adding information to this variable in each step of the definition. So you start with a part of adding information to this variable, and you add more and more information to this variable. But it's not possible to say one thing at the beginning in the definition, and 2 lines later tell just the contrary. It's not that not make sense in mathematics. In mathematics, variable is something that help you to describe a concept, and that is exactly the way to use variables in Prolog. It's like the mathematics concept of variables, and not the concept of classic computer science. So if we ask to Prolog to this one, what will happen according to this idea? What Prolog can tell to us? What do you think Prolog will say to this question? X is unified with 1 and X unified with like list 1, 2, 3. Prolog will say what? Alexander, what do you think about this question? we need to do that more. We have to relax. Probably I'm not relaxed today. We have to relax to make that lesson more interactive. And don't worry, you can express wherever you want and participate. Otherwise, if we not see the faces and you don't answer, will be difficult to follow these lessons. So Alexander, tell me, what do you think? What Prolog will tell to this question?
I really don't know, but I guess true.
Yes, true. Something different to tell to this question or not?
I would say false.
Why?
Because we are declaring 2 times the same variable.
Not something like declare, because we don't know exactly declare the variables. We use the variables in a statement or in a clause in one line. So Pro say false, not a false. And that is false, not because variables are a certain type. It's not because it's not possible to put here a list. It's possible to put inside X a list, and it is possible to say X is a number. There's no problem about that. The problem is not possible to do something like that. It's like X unified with 1, and after that, X is not a free variable. The variable X now have some values, and it's not possible to do after that, something like that. 1, 2, 3, 4, it's not possible. But also, it's not possible to say it's unified with 2. Because like something like it's not coherent with the definition. I'm describing what is X, and it's not coherent to say X is number 1, and after that say X is number 2. It make no sense in the way of mathematic description of use of variables. Okay. Okay, more things. Let me 1 second. I will try to, because there are some. Okay, nice. What is a free variable and instanced variable? What is a free variable and instanced variable? For example, here, if I start the line, X is a free variable, but after a unification, the variable will be not free, and variable here is after that, X is, for example, I'm going to say that it's false because here, after this comma, X have already a variable and 1 is not 1 plus 1. So, but if I do that, something like that, here X is a free variable and it's possible to do that and get a solution. That is true when X will take the value or will unify with number 2. So that is important to have this concept of free variables are instanced variables. And the concept of unification. What is the scope of variables in Prolog? What is the scope of a variable in Prolog? Do you know what means that, a scope of variable in Prolog? No? You have no idea?
It is all the values that can take the variable. No?
Not exactly. Usually in programming languages, like for example, other type of programming languages like C or Python or Java, usually we have functions. For example, function, whatever, function one. We have a definition here. We have the definition of this variable, and usually the scope is what is the part of the code what this variable will be visible. So I have, for example, x in x. That means the variable x is possible to use the variable inside the definition of. It's possible to access this variable inside this function, but not outside this function. This is the scope. In this case, the scope of this function of variable x is the function. one. This is the scope. I can see this variable or use access to this variable inside the function. And if I declare, if I say the int x outside the function, that variable will be a global variable. That means I can use this variable, I'm going to call it another way, is y. I can add access to this variable y from any part of the code. This is the scope. What is the part of the code where this variable will be visible, or I can access to this variable. This is a concept very common in imperative programming, the scope of variable. Probably it's new for you, but you have to know that you can have variable only visible inside a function or global for all the program. But in Prolog, the scope is very strange and very different for other programming languages. The scope is only the line after the clause. The variable doesn't exist. If I say x, for example, x unify with 1 or with 2, x is 1 plus 1. If after this line I write another x unify with whatever, 5 is 3 is 2. This variable is a totally different variable. I use the same name, I use the name x, but it's totally different variable. It's a new one. It's totally different of this one. I can use, if I use that in the code, if I change the name of this variable, everything works exactly the same. For people who program in other programming languages, that is very, very strange to have the scope only for one line, or for this goes from the starting of the line until the dot. If I use 2 lines, the scope finishes here, start here and finish here. And after that, the variable is totally different. The scope of Prolog is okay. I need some impression about all the concepts for people that never programmed before. Please tell me. Natalia Sawatka.
Yes.
Hello, how are you?
Hello.
How do you feel?
Okay.
Are you okay? It's too hard, that, or what do you think about that?
I'm trying to understand.
Is
I think it's not as bad.
it's hard or easy?
A little bit hard for me.
Okay, don't worry. There are many new concepts, so I want to go slowly with this process, because for people who never programmed before, there are many new concepts of variables, scopes of variables, and all the things. So I want to go slowly, because otherwise probably you now you want to say goodbye and see you in other moment, but not in this subject. So I want to go slowly. If you have any question, or you say, okay, Jose, please, Let's go to make a break. Let's go to stop a little bit. I'm back later because I know there are many new concepts, and sometimes it's hard to understand. Another other person that want to give or share their impressions? Another one who never programmed before? Elsa Goba. What do you think?
It's confusing.
It's
but,
confusing?
Yes, but I think it will be everything okay at the end. It's like very much to process in my brain right now.
Yeah. Many things. Yeah, exactly. There are many things to process at the beginning. Many new concepts for you. Probably you never see that before. Probably, and it's not complicated. But I know that many new concepts. So yeah, at the end it works. We need only time. Okay, nice. Next concept. This concept is unification, but I think will be better to. That is probably one of the most important concept in Prolog. Concept of unification, and I need you 100% to explain that to you. So we have only 30 minutes. I propose to you before unification, probably try to create a program by yourself. We can try to. For example, what we can do? We can try to create a program to express the family relationship. That is, for example, we can do, for example, something like Oh, I don't like that. I don't like that program with family relationships. Sometimes it's complicated. Let's go to try with this simple program about I go to check if that works. And then you can try to modify this code. Let me see what happens if that works or not. Let me 1 second. I'm going to create that. Okay, let's go to try to describe or to modify this program, because now here the concept of irrigation or something like that, water some vegetables. Like that means if it rains, some tomatoes are watered. And at the end, we have the fact that that is true. So that means if that is true, that will be true. And all that sentences will be true. So we can, for example, file, consult. Okay, and say what are and I'll say, okay, plants will be tomatoes. And if I write the symbol dot and comma, Prolog will give me all the answers. In this case, we have 3 solutions. Can you modify this program to include more different vegetables and try to describe that what happened when it rains, and can ask questions to Prolog? Can you try to modify this program to add more information here? For example, I can ask also as water it tomatoes. And Pro say, yes, true, it's true. Will it be possible to modify this program to add more information? For example, what happens if I remove this fact? When you modify the program and you want to reload, you can't write make, and that will update changes. And now, so the same, but I have an error here because I need this information. If not, it doesn't work. Okay, can you modify this simple program to add more information? Try to think about that. Try to think about what you can, what more information you can put in this program to try and try to do some questions. Try to modify, add more sentences or more rules, and then let's go to try to play a little bit with this program. So take I don't know, some 5 or a little bit more minutes. Try to add more information here to this program, and let's go to play a little bit with this program after this time. Any question? Luca, I see you very concentrate about.
I'm trying to make it work, but it's,
I'm gonna give you the code here in the chat. You can copy. Sorry. You can copy the code from the chat if you want, and you can use create your own program. And try to add more information. For example, simple add more vegetables to water, put to water, and you can ask more things. And if you have you can use your imagination to add another type of information if you want. Use your logic. Okay, so take around 5 or 10 minutes to do that. And after that, I will reconnect and let's go to see what happened, okay? Luca, what do you think? I see you very, very serious, very concentrate. I don't know about what. Tell me, what happened?
I don't know if I can ask you now.
Yeah.
I'm trying to save the file in the depository. I don't know, but it doesn't. I can't save it in order to consult it, right?
Okay. Can you share your screen and see what is happening?
Okay. Okay, can you see it?
Yeah.
Okay, so this should be the depository, something like that. Okay, this is the.
Can you open the file?
Yes, I open it. Can you see it?
No, I think you have to share not only one program, to share your full screen.
Okay, just a moment. Do you see it now?
Now, yeah.
Okay, do you see this?
Yeah.
Okay, I try to save it.
Yeah.
Just a moment. But then if I go here,
yeah, because you have to write. Okay, try to save again. Try to save the document again. Save as. You have to put the full path where you want to store this document. This, and now / the name of the file, something like vegetables.pl, something like that.
Okay.
And now you can open. Now, perfect. Consult. Perfect. No errors. Very good. And now you can start to make questions there.
Okay.
And if you write dot and comma, the symbol, you can get more results. Try to write punto. Try to write again. Nope.
Again?
No, after that, a dot. And there are an error.
Okay.
Nope, not comma, only dot at the end. And there an error because it's arwatered. You had an extra e after before the parentheses. Okay. Perfect.
Should I write the comma?
No, it's only dot. Only dot.
It's
and now,
just like before.
Yeah, and now if you, I don't know what is in your keyboard. For me, is uppercase and the symbol dot and comma. If you use
Okay.
that's this one. Okay, perfect. You with this symbol, you are telling to Prolog, okay, Prolog, give me more answers, and Prolog give to you all the answer for these questions, not only the first one. If not, you obtain every answer you have. So now you can add more information to your program to try to obtain more results. Okay, so try to modify the code and play a little bit with this code and the questions you can do. Okay, perfect. So modify, and we'll see. You're welcome. We'll back again in 5 minutes or a little bit more. Okay, try to play with this code, modify, put your things, and see what happens. Okay, see you now in some minutes. Hello, how are you? How is it going? There's someone who has some modification to the program? Only 2 or 3 minutes to see your modifications. Any problems?
So I added some vegetable, and I added a new rule that if a plant is watered, then it will grow.
Can you share your screen?
Yes. As soon as you allow me. Okay, thanks. So this is what I did. And I tried some other stuff, but it didn't work too well.
Doesn't work?
Well, now it does, but I tried other stuff like declaring first some plants.
Yeah, you added a new rule. It's very good. Okay, and what happened? It's good, no? It's everything. It's only you have an error in line. You have to start to read this message. You have in line 69.
Yeah, no, that was from the beginning when if I consulted another time, because I had some issues just before. I tried other stuff, but I deleted it. So actually,
okay, now it's perfect. Okay, perfect. Okay, you have no errors at all. Okay, so you added a new rule. It's very interesting. You added a new rule that is, if our watered plants are growing plants. So after that, you are asking for a new concept. You describe using the previous concept of are watered, and now you ask it for what is plants are growing or not, and Prolog say everything you write there are growing. So it's perfect. That is a good example of a way to modify your program to create a new concept using a previous one. It's very good. Okay, nice. I think it's time to go. I think it's time to go because there are only 7 minutes. I want to leave you some minutes if you have a new classroom, online lessons now. So does someone to have any question? You want to tell something or share some idea about what we saw today? No questions? Everything is understood. Nice. Please relax. If there's something that is not going very well, don't worry. I'm going to ask you every day we're going to go slow with this process, so don't worry. We have time to do exercise day by day, day after day. So at the end, we can create this interesting program using Prolog. Okay, nice. So have a nice week and see you. I don't know, next Monday is, you know, if Semana Santa is a free day or not.
I think the
Yes, I
whole
think it's a free week next.
Okay,
Yes.
okay. So see you next week, not the other, after Semana Santa. Enjoy your time, go to the beach, take the sun, enjoy Huelva or wherever you were. Okay, see you after 2 weeks.
Thank you.
Thank
Okay,
you.
you're welcome.
Bye.
Bye. Bye.
Bye.
Bye.
Thank you. Bye.
Bye.